Okay, you can flip to 6.2. Graphs of simple sums of power functions. So power functions are things that we have covered already. In A maths, we started from power -2, -1, 0, 1, 2, 3. So in E maths, we've got this part where we add them up together. So for example, we've got y equals to x. X here over has a power of 1. Okay, so that's power 1. But now we're going to add 1 over x. So I haven't taught you what the graphs look like before. I only taught you for individual one. When it's power 2, I look like power 1, power 3, 0, 1, -1, -2. But what happens when we add them up? So this one, I'm going to teach you to memorize the shapes. You are going to have to plot. Okay, and in this case, you are expected to plot and join the points of your smooth curve. Okay, so for example, draw the graph of function x cubed minus x squared minus 2x. This one is a cubic equation. That's power 3, right? So for cubic equations, we didn't tell you the general shape. That's why you have to plot it out like this, the table has shown. Plotting is not a problem. What I want to teach you for this topic is part B. Use your graph to solve the equation x cubed minus x squared minus 2x equals to 5. Okay? So, what is so special about this x cubed minus x squared minus 2x? Have you seen this portion in part A? Do you see in part A? Can spot? Very clear, right? So you see these two yellow parts, they are the same. Okay? So how then am I supposed to use this graph to solve this equation where there is this part equals to 5? Why should I put y equal to 5? Okay, y is equals to x cubed minus x squared minus 2x. Then here I've got x cubed minus x squared minus 2x equals to 5. So why is it that by drawing the line y equal to 5, I will be able to get a solution? Okay, so this is the thing I need you to think about. If I don't start with a cubic equation, we always try to start with something simpler. Let's talk about you solving the equations. Y equals to 2x plus 1 and y equals to -x plus 3. How will you, if I ask you to solve these equations, how will you do it? Simultaneous. How many methods do you have? What are the two methods? Substitution, elimination. You know how to do it, right? But besides substitution, elimination, what other methods are there? Graphical method, right? How do we use graphs to solve this? Draw the two graphs. Okay. So x and y. Y equals to 2x plus 1. Looks like this, correct? This must be 1. Y equals to 2x plus 1. Next one, y equals to -x plus 3. So it is going to intersect at 3. It is going to slope downwards, something like this. Okay? This is y equals to -x plus 3. Now with these two graphs, how then do I find the solution of x and y? Intersection point. Every time you have two graphs on the same grade, confirm, need to use intersection points. So these are my intersection points. If I plotted my graph accurately, this will be my answer for x, and this will be my answer for y. But do you know why the intersection point gives you the solution? Anybody needs me to explain why? If there's one person who needs it, I will explain. Okay? Now, let's talk about the first graph. Y equals to 2x plus 1, the one that I'm highlighting. Every single point on this highlighted graph has coordinates, right? It is actually joined up. We obtain this graph by making all these crosses over here. And all these crosses, they come from our table of values. For y equals to 2x plus 1, x and y, we start off with -3, -2, -1, 0, and so on and so forth. But we are unable to realistically plot out every single point in the world, right? Right? That's why we join it out with a straight line. Join it out with a smooth curve. In this case, it is a straight line. So if I have only a few points. Oh, cannot already. If I have only a few points, for example, my plotting, only gave me, for example, 1 point, 2 points, and 3 points. If I only plotted these 3 points out, I join it out with a straight line, I will know that, hey, for example, if I want to choose this point, if this is x equals to -1, for example, I can read off my graph, and it will tell me that, this value should be -1, based on my graph, right? Although I did not calculate, but based on my graph, I am able to do that, because every single point on this graph satisfies the equation y equals to 2x plus 1. Okay so far? Now, the same thing happens for my second straight line. Okay, over here, sloping downwards. The same thing over here. I did not plot every single point in the world. I just plot a few points and I join it out with a straight line because I know it's a straight line. And I know that, same thing, every single point must satisfy this equation. Now, when I ask you to solve these two equations simultaneously, I am looking for a particular value of x. I'm looking for a particular value of x and a particular value of y, such that this pair of results x and y, when I sub inside the first equation, left hand side equals right hand side. This means that x and y will satisfy the equation. Am I right? Now, every single point on this line will satisfy. But there is only one point that will satisfy this line, which is this equation, and the other line at the same time. That's why we call it simultaneous. Okay? And that only point lies here. That is the only point that satisfies both at the same time. That's why we use graphs like this, and we get a particular value x, particular value y. They'll be found here. Understand? Get it? Okay. This thing, very important. We're going to use this concept for all the graphs when they intersect. Here we only have straight lines. What happens when it is curved? Okay? So this is what we do for our graphs. If we do it simultaneous equation, will you choose elimination or substitution over here? Substitution. So let me have equation number 1, equation number 2. So what will you substitute into what? Okay, 2x plus 1 equals to? Negative x plus 3. Why can we do this? Left hand side, they're all y, right? So every time you see a y, you substitute. So you see, this is the next very important part, the key to understanding chapter 6.2. Since they are both equations, they start with y, I can equate the two right hand sides together. So the y disappear already, right? Now I'm left with 3x equals to 2. X equals to 2 over 3, which means that this is equals to 2 over 3. So here I am solving for an x value, yes? Then is there a corresponding y value? Yes, I can sub into either equation number 1, then I will get this value of y, or I can sub into equation number 2, I will still get the same value of y, because it is the same point. Am I right? Okay, now that we understand all these basics, we can talk about what happens if the question says, the question doesn't give you these two simultaneous equations, so this one pretend it doesn't exist. What if the question says, use a graph to solve the yellow equation? What will you do? Not algebra, use a graph to solve the yellow equation. What will you do? You draw y equals to 2x plus 1. You draw y equals to negative x plus 3. So you get those two graphs, right? We are working backwards now. So we get those two graphs, we find the intersection point. Understand? So instead of from simultaneous equation 1 and 2, then you do substitution, you get the yellow one. Now it is reversed. I gave you the yellow equation. This one not given, I give you the yellow equation, you work back to introduce the two y values. Then you draw the graph. Understand? Okay, let's try. here we have example 4. We already have the graph of y equals to x cubed minus x squared minus 2x. That is the curve you see over here. This is the one. Now we are supposed to use the graph to solve the equation x cubed minus x squared minus 2x equals to 5. Hey, no more y already. What do you have to do now? What do you have to introduce? Introduce y, right? Okay, since we already have y equals to this graph, what must the other graph look like? Y equals to 5. Okay, the objective is always to extract x cubed minus x squared minus 2x out from the equation that is given to you. Okay, but in this case, you don't have to extract, they already give it to you. Nothing for you to change. So draw the graph of y equals to 5, which is shown here. Can so far? Okay, then what is the solution? Where is the solution? Intersection point. And what do we read as the intersection point? 2.55. So take a pencil, put a part B over here to indicate that whenever you draw a graph and you have an answer in the graph, I want to see the label. Otherwise, you put 2.55, I don't know what question you're doing. Okay? Part B, 2.55. That is the x value. Is there a corresponding y value? Yes, there is. But are we interested in it? We're not interested in it. Part B only says solve the equation x cubed minus x squared minus 2x equals to 5. There is only one unknown, which is x. We are not interested in y at all. Can? Okay, now what we're going to do is try it for, no need to do the graph. I just want you to do part B. Tell me what is the graph you will introduce. Assuming we've already drawn this, we've already drawn y equals to x cubed minus 4x. Now, what graph are you going to draw to solve? Part B. Draw y equals to 10. Okay, put down this as your answer. I'm not going to ask you to waste your time, draw the graph, everything. Write down, draw y equals to 10. X coordinate of intersection point is answer. Okay? Understand what this statement means or not? Understand or don't understand? Seriously? Okay, understand? Intersection of what? Intersection of what? Which graph? Which graph? Of y equals to x cubed minus 4x and y equals to 10 will be our answer. Okay? Let's try something more challenging. Okay, I'll just go through the examples really quickly. Here we draw the graph. Find the coordinates of the turning point. Okay, now for example 5, part A, you plot this graph, okay, according to the range. Then they say find the coordinates of the turning point. Where is the turning point? Can you identify it? Class, can you identify the turning point? How many are there? Okay, quite clearly over here and over here, right? Did I ever tell you what turning point means? Why do we call them turning point? It changes direction. It goes from, in this case, let's start from left to right. What is the gradient over here? Positive or negative? Positive. Then when it comes to this point over here, what is the gradient? 0, right? At the turning point, the gradient is 0. So from positive, it became 0, then it became negative. So there's a change in sign. From positive to negative, there will be a turning point over there. And the gradient at my turning point is, turning point is 0. Okay, let's try the same for this side. Here we've got negative, right? And when it comes to this point, what is the gradient? 0 horizontal. Then from negative, it became positive. So this is another turning point. This is how we identify turning points. If you want to explain it in words. But visually, I'm sure you can tell what are turning points. Okay? Then, if you were to plot this graph, you plot this, imagine without the curve given to you, will you be able to tell that this is the shape of the graph? If you only have the red crosses? Can you really tell it looks like this? Then what should we do if you can't tell the shape? Plot more points. Okay? Plot more of them. Then you realize that, actually it seems like it doesn't touch the y-axis. Okay? You plot some more, it looks like it goes closer and closer to the y-axis, but it doesn't touch. And we can very easily get the answer, because when x equals to 0, y equals to, substitute inside here, what do you get? 0 plus 1 over 0. What is 0 plus 1 over 0? Defined or undefined? Did somebody say 0? It's undefined. Okay? So it's either positive infinity or negative infinity. So that's how we get this shape. Okay, now try it 5. We're not going to plot again. Assuming we have drawn this graph. Doesn't matter what the shape looks like for now. Okay? Assuming you have drawn it already. Do B part 2. What will you draw? What other graph will you include? Which is good. So, from our given a graph that we have already drawn, y equals to x plus 1 over x squared, we see that they want us to use a graph to find a solution to this equation. No more y already. So you introduce the y yourself. Okay? But we can't just simply introduce the y like that. Y equals 0, y equals to x plus 1 over x squared minus 3 doesn't help us at all. So we see that there is a similarity between this equation, this part of the graph they have already drawn, x plus 1 over x squared, and you see it somewhere here, right? See, it's over here, x plus 1 over x squared. I want you to extract that out. I want you to isolate it. That means I want you to get rid of the, what do I want you to get rid of? Negative 3. How do you get rid of negative 3? Plus 3 on both sides. So x plus 1 over x squared equals to 3. So you plus 3 on both sides, and you see that, I've already managed to isolate this. And it is the same as my graph. Y equals to this. So y is also equals to 3. Draw this graph. The intersection point will be the solution. Get it? More examples. Example number 6. Here we have the equation y equals to x squared over 6 plus 3 over x. Ask you to plot. Okay, fine, plot. Then next part. Draw the graph of y equals to 1 over 4x plus 2. So now we have two graphs on the same grid, yes? But there are two different equations. Then write down the x coordinate of the point of intersection of the two graphs. This one, from the graph, we can write down. Okay, these two graphs, there's a curve and there is a straight line. Points of intersection of the curve and a straight line, we've got 1.5 as well as 3.5. This is for question D part 2. So put out a D part 2 over here. D part 2. Okay, intersection of the curve and the straight line. Now, what do the intersection points here give us? This 1.5 and this 3.5 for the equation of this curve and the equation of straight line. What are we actually finding? What are we doing? Solving what kind of equation? Simultaneous equation. Every time we have intersection point, it is simultaneous equation, okay? So meaning, if I give you an A maths simultaneous equation question, this is equation number 1. This is equation number 2. What will you use? Substitution or elimination? Substitution, okay? What sub into what? Are you sure one sub into 2, 2 sub into 1 is the same thing because the y are the same, right? Both of them have y as the subject already. Okay? So if I ask you to solve them simultaneously in A maths and you sub them into each other, what equation will you get? What will you see? What will you write? Left hand side. X squared over 6 plus 3 over x equals to 1 over 4x plus 2. Okay. Without doing any more, what type of equation is this? Linear, quadratic, cubic. Why quadratic? Really? Because of the square term? Why cubic? Because there's an x in the denominator, right? What will you do with that x? Multiply throughout. Then you get x cubed over 6 plus 3 equals to 104x squared plus 2x. Am I right? So there you have a cubic equation. How will you solve the cubic equation? How are you going to solve the cubic equation? Find the factor. Yeah, then you have to do trial and error, right? Now, you see in this case, we already have the graph. Right? We know the answer will be x equals to 1.5 and 3.5. Do you think you can guess until you get 1.5 and 3.5? Not very likely. Your calculator can do it for you though. But what is more realistically to be done is that you plot the graph and these will be your solutions, correct, to the cubic equation. This is what it means for the intersection point. Now we're ready to go on to D part 2. Part 3, sorry. Find the equation which is 2x squared plus ax squared, 2x cubed plus ax squared plus bx plus c equals 0. Find the equation which is satisfied by the values of x found in part 2. Okay, take a few seconds to think about this question first. What is it trying to tell you? Okay, think about it. Who doesn't understand part 3? It's okay if you don't understand. Raise your hand. First time I see, I also don't understand. Okay, part 3, they want you to write out an equation. The equation looks like this. 2x cubed plus ax squared plus bx plus c equals 0. What kind of equation is this? Linear, cubic, quadratic? Cubic, obviously cubic, there's a cube. Okay? If I want you to solve this equation, but I give you the value of a and the value of b and the value of c, then you only left with x, right? If I ask you to solve a cubic equation, do you know how to do it in AMATS? Yes, you do. We just talked about it only. Okay? But this time, instead of asking you to solve the equation, they ask you to create the equation. But this time they give you the x values. They give you the x value, you form the cubic equation. What are the x values? They are found in part 2. So in part 2, they are 1.5 and 3.5. These are the solutions. Okay? They give you the solution, you calculate the equation. How do we work backwards? What's so special about 1.5 and 3.5 again? Intersection points means, intersection points means we are trying to solve simultaneous equation. And the two simultaneous equations are over here, 1 and 2. So we put them together. And is this a linear, quadratic or cubic equation? Cubic, we just talked about it, right? Because we're going to multiply the x over here. Now, I'm going to multiply the x and we shall see what kind of cubic equation we get. So x cubed over 6 plus 3 minus 1 over 4x squared minus 2x equals to 0. Agree? Okay? Now, this is cubic. I've got x cubed, I've got x squared, I've got x, I've got constant, I've got equal to 0. Why I want to put equal to 0? Why do I want to put it be equal to 0? They want it to be equal to 0, right? What are they similar now? The 2x cubed plus ax squared. It's 2 more. Are they similar already? This one and this one?
Yes.
Quite similar, right? So does this mean that a is my coefficient of x squared, so negative 1/4? Why not?
Because x cubed is 2.
Oh, x cubed, coefficient of x cubed must be 2. But it's currently 1 over 6. What shall I do? Times 12. Okay, let's multiply by 12. So multiply by 12, I get 2x cubed. Can you help me out over here? What's next? The x squared term. I want the x squared term. Times 12. What do we get?
3.
Negative 3x squared. Then I want the x term now. I want a constant now.
6 plus 36.
Okay. Do you see that these two equations are the same now? What is the value of A? B? C? Okay, yeah, so this is the correct answer. Okay, can? Now, homework for today. I want you to go look at exercise 6.2. I only need you to do part B, but although they say use your graph to solve, right, I don't want you to plot. I give you simple homework. You just tell me, draw y equals to whatever. Okay, it's the same type of question. Okay, so that's for 3B, 5B, 6C, 7B, 6C part 1, and D part 3, 13D part 3. All these questions, I don't need you to plot. I only need you to tell me, draw y equals to something. Okay, then the solution will be the x coordinates. Huh? Yeah, just need you to write, draw this. Then as long as you know the x coordinate of the intersection points, the answer can already. Okay? You just practice this for now. Any questions? Okay.